let's start reviewing here by talking about standard form versus factored form. Here is an equation in factored form. Why isn't it in standard form? Well, there's some reasons we like factored form. What do you know from this? We know the x-intercepts. We know that they're bouncing in certain places. If I asked you to multiply this all out, can you imagine that it could come out to something like negative x to the third plus blah, 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 blah. And then let me think what the ending would be. Can you do it quick in your head? What would the ending of the equation be? Don't say it. Think it. I got it. You got it? Raise your hand if you got it. Charlie, what'd you get? Yes. And that negative in front would go on the 18. This one goes away because it gets squared. And I get negative 18. That means its y-intercept is down low. So if you were going to graph this thing, that would be helpful. So do you get standard form has that one advantage? It's just sitting right there. See how standard form is a little bit better in a way? And it's also a little bit better because I can see the degree right there, just sitting there. This one didn't have the degree super obvious. You got to work for it. Okay. So that's a little short discussion of some of the benefits and disadvantages of them. But what if I give you this one? Negative 3x to the third plus 4x squared minus x minus 2. Would you please tell me the degree? You don't have to write the whole problem down. You can if you want these for the notes. That'd be cool. The leading term, the lead coefficient, the right end is doing what? And I want you to say it as a limit. As in, if you know that it's going up, then you'd say the limit of the function as x approaches infinity is infinity. That kind of thing. The right end limit. Then just tell me the left end is up or down. I don't need you to show me you know limits again. If you know limits the first time, you still know them. And I'd like to know the x-intercepts and the y-intercepts. Now, some of these you might just say, Mr. Server, that's impossible. Yeah, and others you might be like, that's super easy. All right, I'm going to pause for a sec while you think through those important terms. Oh, yes. On the other one, I'm going to ask a different question. But in this form, I'm not going to ask you about multiplicity because it wouldn't be really relevant. But when I put it in factored form, it would be. So the degree of this thing, let's just kind of go down a row here. Arlie, what's the degree? 3. The lead term, Marcus. You were close. That's the lead coefficient. You want to try again? Nope, the lead term is negative 3 and it keeps going. All right, you're learning something. That's the lead term versus the lead coefficient is just the starting number, negative 3. All right, we'll move on to, let's see, Mr. Yaw. We're doing the right end limit. So I'm going to write it in different color here. It's the limit. X goes to infinity. That'd be the right end limit. Good. Equals, and then it's going to positive or negative infinity? Negative infinity. Because of this right there, it's going down on the right. Good. Okay. Then the left end, all I really care on this one is up or down. Matthew? Why? Prove it to me.
Because the degree is odd and so that means the opposite direction is
Very good. What he said, in case you couldn't hear him at home, is he said, because the degree is odd, it's going to go in the opposite direction as the other end. And the other end's down. So, nice job. All right. Let's go to the back. Rita, what do you get for x-intercepts? And if you did have time, what would you have done? Very good. If you can factor, you should. But this one doesn't factor, so don't worry. You didn't miss out on anything. So if it doesn't factor, does that mean it doesn't have x-intercepts? No, it's got x-intercepts. In fact, I know it has to have an x-intercept because it's down on one end and it's up on the other. It has to go through somewhere. Could it go through just once? Yes. Could it also have 3 x-intercepts? I gotta hear you talk louder. I do know what you mean, but this one won't. You go ahead and try it, but I really don't think you're gonna be able to factor it. All right. So I hear you that there's 4 terms, and sometimes when there's 4 terms, you can factor by grouping, but I didn't set this one up to do it that way. You know how I can tell? If you look at the ratio of 3 to 4, if this had the same ratio, which is a 1 there, to 2, if that had the same ratio, then there'd be a chance. So all I would have had to do to make that work is, let's say, if I'd have made this a 6 right there, then this thing probably would have factored by grouping. Because then the ratio 3 to 6 is the same as the ratio from 1 to 2. Yep. If I rearranged it, I don't think I could still do it. I want you to prove it if you can do it on your paper. Go ahead, try it, prove it that it can be factored the way it is. Not with a 6 in there, I just said. If I put a 6 in there, it would be. But without the 6 in there, I don't think it factors. Okay, so back to y-intercept. Ready?
The y-intercept is when x equals 0.
Excellent.
In 0 for x.
Put in a 0 for x. All of these things cancel, and the answer is?
-18.
Okay, pretty sure that if I put in x equals 0 on all of these, I think they all just disappear. Don't they? Oh, you're thinking of a different one. You're thinking of the equation before this. All right, I'm talking about this one right here. So the y-intercept is -2. Now the y-intercept is where x equals 0, so you could definitely say 0 comma -2. All right, good. I got a lot to cover today, and I want to have some time for questions, so I'm going to just keep on plowing ahead. The next one is where it's factored. Negative, parentheses, x plus 7 squared minus, no, I wouldn't do that. Then it wouldn't be factored. Times x plus 4 to the third. I want you to tell me what's this time, again, the degree. You'll have to like do some thinking. You can't just see it there. The lead term. The lead as in coefficient. I'd like to know the x-intercepts, the y-intercepts, and we already tested the concept of like down on the right, up on the left, so the end behavior, we already got that. I'd like to know the zeros and their multiplicity and their behavior. Behavior means like bounce or pass through. We are not making a determination between a to the third power and a to the first power. To the first power just passes through, but the third power technically snakes through. I wouldn't mark a third power of snake wrong, but a third power does just pass through in a funky way, so we're just going to call it a pass through. I'm experimenting with this because I basically had calc teachers pushing back saying they don't need to know anything more than it passes through. So why are you making them learn this word snake? And I thought, okay, if all that really matters is that it passes through, then I won't care if it's to the 3 or to the 1. All right, so let's try this one. Where did we leave off? I think in the back, Campbell. What did you say for degree?
5.
Degree 5. Min, would you just grace me by telling me the lead term, because that'll tell me a lot?
Negative x to the 5th.
Very good, and you got that by doing... I'm just trying to show people, because I know what you did. There you go. That all put together. All right, and then the lead coefficient. Get off the highlighter, Mr. Server. Let's go to the next person. -1, and that's the number in the front of the lead term. Okay, good. The x-intercept, jump up to Miss Tan.
I have
-7 and -4. And since they're x-intercepts, their y's are 0, so I'm going to put comma 0 and comma 0. You don't have to write them that way, but I think it's nice and clear that it's a point. The y-intercept, Sam.
-3, 1, 3, 6.
Ooh. And if you had just said negative big, I would have allowed that. Why? Because I don't think we're going to have a calculator on this one. And if so, that would have been just too big. And do you get knowing it's a big negative number helps you on the graph? And you wouldn't even really need to know exactly what the big number is. If you're sketching it, you'd be able to sketch it knowing it's a big negative number. Can anybody verify the 3136? All right, good. And then the zeros, I'm going to put them on a list. They're the same as the x-intercepts. So -7 and -4. One more thing, if I had put an x in front, would that have made an extra 0? Yes, it would have, and it would have been a 0 at 0, which confuses people sometimes. I'm going to add that to my chart just to talk about it. So I'm going to throw in an x in the front. Now, that will change every answer. You know what? I better not do that. Those of you that take good notes are going to be frustrated. So just know that if there was an x in the front, the 0 would be 0. All right, so then we'll go back to the multiplicities of these things. Multiplicity just means the power. So if you knew that the 7 had a 2 multiplicity and the -4 had a 3 multiplicity, you're good. And the behavior at a through is a bounce. And then there's a pass-through on this kind. And I would have been fine with snake. Any questions about when they're in factored form like that? Okay, so let's go back to our concept list and see what else do we have to know. We'd already practiced end behavior and limit notation. And if you're not good at that, we have a whole worksheet to practice it. Multiplicity, we already just talked about that. It's basically the power that's on the little factor there. And the behavior, we just talked about that. Sketch it. All right, well, let's sketch that one. Everybody sketch that one that we just talked about a lot. Take a minute, sketch it. On this kind, you'd be able to tell the x-intercepts. On the kind that doesn't factor, you wouldn't know the x-intercepts. One last thing we talked about just briefly before was turns. And I think it's dangerous because then some people think it's degree 5, so it's going to have 4 turns. No. Max of 4 turns. It could have 4 turns, but it doesn't have to. So people get confused when they don't have 4 turns then. So it's true, it has a max of 4 turns. But I don't want you to perseverate on the fact that it's got 4 because it probably doesn't. Often has less than 4 turns. Okay. The roots here, we're at -7 and -4. Scale on that's pretty terrible, so I'm going to try again. Okay. And then it's down on the right, and it snakes through this one, which don't worry, I'm not going to test you on that. It's part of the reasons I'm fine with just saying it passes through there. And then it bounces off of this one, and I feel like it should be going up. Now I'm going to test myself. First, I'm going to see, did I hit in the way that I'm supposed to? I know I'm supposed to go through -4 and -7. This one, I just passed through it because it's degree 3. This one, I bounced off of it, so I'm good there. Next, my right end is down, which is from this. And the total degree was degree 5, so they should be going opposite directions, and they are. Now, one last thing. Remember that y-intercept was -3,000 something? Do you get that I'm not assuming this goes straight down here? It's going to be slowly moving to the right, so it would eventually hit the y-intercept. But I don't have to show that if it's -3,000. All right. If ideal world, you would have probably continued. Now, in the directions, it'll tell you if you have to note the y-intercept. If you do have to note the y-intercept, it'll be small enough to find. It won't be 3,000 and something. -3,136. Okay. Any other questions about graphing or sketching them? Yes?
This is just about the text.
Yep.
Do we get a graphing?
Am I going to provide you with a graphing calculator for the test? That's what you really just asked me, so I can give you a simple answer. No, I'm not. You said, do we get a graphing calculator for the test?
Are we allowed to use our...
That is a better question. Are you allowed to use a graphing calculator if you bring one?
Yeah.
And if I do, of course, kids that don't have one will get to borrow one of mine, but I can't promise one for everybody. Let me look at last year's test and see. I am not certain. I know we talked about it, and I think we talked about not allowing it on this test, but I am not certain. How about this? I'm going to get you that answer by the end of the hour. I'm going to say right now, I don't think you get a calculator.
Okay.
So far, nothing we've done here has required a calculator.
Yeah.
All right. But I'll get you a definitive answer before the end.
Okay, thank you.
Sure. All right, let's talk more about what else is on our list, the stuff that you have to know. Use long division. Ooh, long division, that seems important. Let's just make sure that you can do long division when they're weird. Just think about it. Would you agree that x squared minus 1 factors? It does. And I'm going to put x minus 1 out here. So you know already what the answer is, but don't cheat. Just think through, well, what I put here, because what's going to get weird is, like, there's a missing term in here, and I want you to be able to handle it when there's a missing term. So do this the normal way of using long division. Because the ones we give you on the test, you will not be able to do them just in your head. Okay, so to start with, you put an x on the top. How do I know that that works? Because I go x times x, it makes x squared. Cool. And then I go x times 1, and it makes minus x. And the problem is that you're like, well, that's fine, but that's not lining up with anything. So, like, what am I supposed to do? Well, think of it as there's a 0 above it, and I add x to it, I'll have an x. And then this negative 1 just comes down. Okay? And then, oh, that's actually going to work pretty nice. And then I go, even though there was nothing to line up with each other, I just got to find where to bring them down. And now I'm going to go plus 1, and 1 times the x makes the x, and 1 times the negative 1 makes negative 1. A lot of people right there put a negative 1, and they're wrong. So be careful with that. I want to match it exactly. See how these are exactly the same as each other? Then you go opposite, and you get 0 at the end. Okay, so here's another one. In the dividend, which is in the den, x to the third plus 4x squared minus, squared minus x minus 4, and I'm going to put x squared minus 1 on the outside, because I think it'll lead to some craziness. Wait. Yes? Oh, yes, there is more than one way to factor. But remember, I know what's on the test and you don't. So I'm encouraging you to use long division, because if it was just a factoring test, sure, go factor it any way you want. But you're going to have to know how to long divide. So if you want some more practice problems, of course, they're in the file. We've got a nice review file. It's got some ones for you to practice. Anya can tell me how to start. What goes up here? Good. And then I got x to the third, and then minus an x, and then how do I deal with the fact that that didn't really work nice. Move the plus x over here, I agree. I know it's mildly annoying that I'm repeating you, but for the video's sake, they can't hear you, so. Then I'm bringing this down. And then that does cancel. Cool. And then I bring down the -4. Anytime it factors like that, it's a good sign. All right. And now the bad part about just going around the room in a snake pattern like that is everybody knows who I'm going to call on next. So I'm going to kind of shake it up, try to spread the rest of the joy out around the room. Audrey, can you tell me what to do next?
You keep the 4x squared minus 4, and you see how it's x squared minus 1, so you put 4 on top.
I need a 4 up there, because then if I go like that, I get the exact same thing. Notice, I don't want these to be opposites at first. I want to be the exact same. And then -4, and then it'll be opposite, and then I have a 0 remainder. Cool. And then the kid writes this, x squared minus 1 times x plus 4, as they should. And then they get it wrong. McLean, do you know why?
All the inputs going back.
Okay, and what did you notice?
Oh, x
Yeah,
squared minus 1 is
it factors to what?
x plus 1.
Yes. Now is it factored all the way? Yes. What are the roots, the zeros, the x-intercepts, the solutions? Marcus, can you remove that white thing from your ear? And it's -4, 1, and -1. Raise your hand if you had those in your head. Okay, good. And then does that number of roots match up with the original problem? Yup, it addeth to the third, so you should get 3 answers. Could 2 of them have been imaginary? Yes. I want to make sure I make this point, though. You will never have one imaginary answer. If you are going to get an imaginary answer, it's going to happen fundamentally because, this is the way to think of it anyways, x equals negative b plus or minus the square root of a negative. See what I mean? That's how you're going to get an imaginary answer, right? So let's say it ends up -25 in there. Do you get, you're going to add it to something and subtract it from something so that you're going to get 2 answers. If there's ever imaginaries, there's going to be 2 imaginaries. Okay. Back to our list. Write a polynomial based on, that's the new thing I just did yesterday. Okay, here's some characteristics. The question?
Yeah, will we have to use imaginary numbers on the test one?
You are expected to know how to do imaginary numbers. So let's say I said x squared plus 1 and x minus 5 was what it factored to. And I said, what are the solutions? Would you be able to solve this one?
Yeah.
That's pretty easy. Would you be able to solve that one? Then maybe I should help you. X squared plus 1 equals 0. X squared equals -1. Do you know what happens next? Should. Square root. What's the square root of -1? This is the absolute value of x. Very good. And then what's this? I. The square root of -1 is I. If it had been the square root of -25, it would have been it would have been 5i. The I comes out to take care of the negative. Think of it this way. Square root of -1 times square root of 25. And the square root of 25 is 5. And that's I. So I5 or 5i. That's really how you'd write it. Yes?
So, does that mean there'd be only one, what is it?
There will always be 2 imaginaries.
So,
All I'm saying is that if I had a square root of a negative, this is how to handle it. So on this one right here, see why there's not just one answer? Because why?
because you have plus and minus.
Doop. X equals I, x equals -I, ergo plus and minus I. Yes.
So, if you ask us a question that says,
I just was throwing in, what if we had a square root of -25? That would not come up in a problem because you can't ever have just one. It would add a minimum plus minus on.
if you ask us for the solutions, would we say there's a problem with negatives, or would we also say I?
If you only had this question on the ACT, the square root of -36, then there's only one answer. 6i. Boom, done. But in the context of solving polynomials, there's always packages of 2. Always, always. So this would never happen. We'd have plus and minus that on our test.
There's only one solution, the real solution.
There is only one real solution to this. There's only one solution. It's 6i. But when you're solving a quadratic, you're solving, and that's different. What we're fundamentally coming to, the difference here is this. If I say this, do you get there's two answers? If I just said this, do you get that's completely different, and there's only one answer? Good. Yes.
On the test, is it gonna be a box problem?
Okay, so you just asked me a specific, like, is this on the test? I never answered those questions.
No,
Do you have to?
will we need a calculator?
Just that doesn't matter. If you had a box problem, you wouldn't need a calculator. Okay? Okay. So for example, on the box problem, which is the last thing, so let's just finish that up. Write a polynomial to maximize volume of a box with given dimensions. Okay, so let's do that. So let's imagine I give you a sheet of cardboard. I've got the sheet of cardboard and it looks like this, and it's 7 long here and it's 12 long there. And I'm going to cut out the corners. We're not going to make up a completely weird combo for you, even though I think that'd be fun for some of you. It might be a good R4 if we made the box look different. But how could I possibly ask you to do this problem without a calculator? Well, because I think you could write the equation for it right now. And I think you could sketch the equation for it because it's just a polynomial, and we've done polynomial sketches, right? All right, let's just make it a smidge simpler. Instead of the 7, let's make it an 8 because of something that's going to happen, and it'll be a lot easier without a calculator. Okay, so everybody, would you please tell me the volume of this box? And I know there's lots of X's in it. And I'd like you to sketch it. Once you get the equation for it, you're going to sketch it. Now, I know we the other day went further than that, and I said, okay, now let's take the calculator and graph it and find the maximum. I was just stretching you. That eventually will be on one of your tests, but it's not on this test. All right, so I have Madeline. Tell me one of the little parentheses. You are correct. You took the easy one. Okay, fine. Sam, give me another parenthesis. 12 minus 2x. And Mr. T, the other equation.
8 minus 2x.
Yes, and that's not really an equation. I meant the other part of the equation. Okay, good. And now sketch it, everybody, because you know the roots. I know the roots. You should know the roots. What do you mean the roots? Well, the roots are the same as the zeros. They're the thing that make this equation 0. Would you agree that one of them is 0? Find the other two roots. And then sketch what this thing looks like. I know from the end behavior that it ends going, well, you'll have to figure out if it's negative in the front or not. So you'll have to think through what's the lead term. So a 0 and one of these is 4 and one of these is 6. How'd you get that? Well, because if I solve this and make it equal 0, this would have to be a 6, right? So if I set 12 minus 2x equal to 0 and solve it, you get x equals 6. So 6 is one of the roots, and the other one's 4. And now I can do a quick sketch of it, and I know that it has to end going up. I don't see any bounces, so it must do this. And then there's real life where you can't have a side of 5. Can you explain to me why 5 is impossible? Well, you could look at this and say, because you'd have negative volume. Weird. But true, you can't have a side of 5 because it's not in the what for x. The domain. It's not in the domain. The domain of this thing is x would have to be between 0 and 4y. Let's get K to weigh in on this one. Why can't x be outside that little range? Why can't it be negative? Can't have a length be negative. Okay, good. And what else? Why can't it be 4, like 4? Why can't it be 4?
Because that's like box.
If it's trying to be a box,
It's got to be a box. It has to have some space in the middle between where those two sides.
so if I go 4 in this direction and 4 in that direction,
That's directly top. No space for.
all right, if you really cut where I just drew blue lines there, you just chopped off the whole edge of the box and you got another new piece of cardboard that's different size. So you don't have a box. All right, good. All right, cool. I think we talked about that, and notice no calculator needed. So do you get that the answer, which would be for what? Is this chickens down here? And this is time up here? There's like so many things wrong with that. Of course not. What was it in this problem? What was the bottom? And don't just say X. X, which is what? Cows? Yes.
Of the length x, length of x, or like the square that, about that you can cut out.
And what is the Y value? Charlie, do you know what the Y is? No, the Y value's label, like cows, meters. So we're making a box, and what do we want to have our box, like, it has to hold something, right? There you go. The volume is on the Y, so you can see why this would be the area that would matter, because that's the size corners you could cut, and you eventually get a highest amount in there. And I feel like it should be exactly at 2, but I don't know until I would actually, that's the part where we aren't going to go that far, graph it with a calculator, find exactly what the maximum is. And it might surprise you, it might not be exactly at 2. Okay. Yay, I think we figured out some stuff. And you have a review worksheet and you have a little Schoology quiz from yesterday. I'd like you to do that one. That Schoology quiz from yesterday is not optional. It's like going in your grade. But today's stuff, you're doing it because you want to do well on the test tomorrow. Okay, it's not about Dropboxing it for me. It's about you being ready for the test. So I am not assigning you everything. I'm giving you a big menu and say you should do a bunch of stuff from that. Maybe you should do a limit problem off the limit worksheet and then check it with the key. Maybe you should do the ones that scare you the most. Really, you shouldn't do ones that are super easy for you unless you need affirmation. Okay? If you are feeling low, like, oh my gosh, this class is so hard, take a couple easy ones to get your feet under you and then do the ones that scare you. All right, that's all I have for you for the video for today.